let's talk about object-oriented design. So far, we've been using functional design. So in functional design, we've been focusing on the algorithms, and we've been taking those algorithms and subdividing those into logical functions so that we can reuse and organize our logic, and all our data is passed to those functions using parameters. For object-oriented design, the focus is on the objects. Well, what are the objects? Well, that would be the nouns of the problem. So, for example, in our Flying South program, we wrote a program where we had a set of birds that formed the shape of a V and flew south on the screen. We animated them to move down the screen. So in that case, the nouns of that problem, well, that would be the bird. The bird is the noun, and that would be the focus of the object-oriented design. The objects, for example, the bird, is going to contain both the data that tells us about the bird and also the algorithms that are related to the data. We're going to encapsulate those two things together into the object. Even though it's object-oriented, algorithms are still organized into logical functions. The difference is that we're looking at the object as the highest priority for the organization. First, we look at the object, what it does, what algorithms each object needs, but then we can also still divide those algorithms into further smaller functions based on what we logically want to do. For our Flying South example, when our birds are flying south, that would be an action that the bird is taking. The bird is flying south, so we would logically write a function for the bird that would take the action of moving that bird south on the screen. Object data does not need to be passed to the functions because the data is stored on the object where the functions are defined. So we can still have other data that we can pass as parameters, but all the data related to the object is going to be stored right on that object type. So when we do object-oriented analysis, the first thing we do is identify the objects. So when we're flying our bird south, what are the nouns of that program? Well, that would be the bird. So that would be the object that we're going to look at. And then let's look at the data of each object. Well, we store the X and Y position of each bird that identifies where it's supposed to be drawn. So that would be some data associated with the bird. If we wanted to put a color on the bird, we'd also want to store it with the data. There's lots of things we could store, but so far our program has been pretty simple, and we have just stored an XY position and the bird is fixed. The next thing we wanted to do is identify the actions of each object. So what are the actions of the bird? Well, one is to draw itself on the screen, right? That's the function of drawing it would be an action related to the bird itself. So we would want to associate that algorithm with the bird object. The other one that we talked about already is the action of the bird moving south, and that would be another function we would want to have related to our bird object. Encapsulation is the principle of putting that data together with the functions, and thus is born object-oriented programming. So how do we actually do this in JavaScript? How can we put the data and the functions together? Well, there's many different ways. JavaScript keeps evolving, and there are different ways to create objects in JavaScript. So we're just going to stick with one way in this class, and we're going to use the same way that Khan Academy uses to help reinforce. The book offers alternative ways to do it. You could use those, but we're not going to cover those in class. So for object types, we're going to use the function definition. And there's something special about this function definition. We're using a keyword this. This allows us to store data with the function. Well, that's the whole idea of the object, right? We're storing data and functions together. So the this is the place where we hook the data in. And also notice that I've capitalized this variable name. Now normally I say that I want you to start variable names with lowercase. Well, in this case, this is a prototype object, and therefore bird is actually a type, and so we will be creating variables of type bird. So bird is just defining like the stamp, like the recipe. How is a bird going to look? What are the functions and what is the data that we're storing on it? But it doesn't actually give us a bird. Just like when we define functions, it doesn't actually execute the code immediately. It just gives us something we can call later. So it's the same thing with the object types. We're creating a bird pattern that we can use later to create birds. Note that objects are not the same as object literals. Object literals are not a pattern. They are the actual object, and you're sticking the data in there immediately, whereas the object type is the pattern. And we're focusing on the object type right now. So now we have this bird object type, and how do we add a function to it? Well, as we talked about, we want to be able to have the bird be able to draw itself. So I want to add a draw function. Well, bird is my object type, and in order to create a function that can be called for any bird, we use this keyword prototype. So we start out with the name of our object type, and up here we defined our object type to be bird. And so we start with bird, say on the bird, create a prototype called draw. And that draw is going to be a function. And then this code is just what draws the bird. It's just our arcs that give us the bird shape. This draw function is also called a method in object-oriented terminology. When we create this prototype, notice that we're accessing this .x position. That's saying on the bird object, whatever was stored in this x position is what I want you to pull out and use here. Same thing with this .y position. Oh, well, we put a 100 there, and so this .y position is going to be 100. And then we did the slight adjustment on the second arc so that the bird would match up with 2 wings. This is our function that is related to our data. So we're putting the function and the data together to create an object type. Functions on objects can be called methods in the object-oriented terminology. So sometimes you might hear method. In JavaScript, it's still the keyword function, even though it can be called a method.